Good morning, good afternoon, or good evening, depending on time of the day you are watching this video. Today we will discuss Address Resolution Protocol, in other words ARP. This video is brought to you by CMS Computer Institute located in Hennur in Bangalore, and you can reach us at cms.hennur@gmail.com. So what is Address Resolution Protocol? Address Resolution Protocol is a protocol part of TCP/IP protocol suite. What that means is, whether you are aware of or not, most likely you are using ARP in your computer. Every computer connected to internet uses TCP/IP because internet runs on TCP/IP, and if you are running TCP/IP, ARP is an essential and very integral part of TCP/IP, so you would be using ARP. Right? So what ARP does is, the job of ARP is to create a mapping between your IP address and the layer 2 address or MAC address. Now we'll look at why actually you need to create that mapping. So you'll use this diagram to explain that. So this is a computer, and this computer has a TCP/IP protocol stack, and it's connected to an Ethernet network. The four layers that you see, the network starting from network interface layer, which connects to your physical wire on Ethernet, and internet, transport, and application. These are the four layers of TCP/IP protocol suite. Now application layer is the one that generates all the data. Basically, an example of some of the application are going to be your web browser is a classic example of an application. If you want to go to a website, you type in your web page name, your application, your browser generates a data with a request to go to that page. So that's an example of application. So basically, all the data that we generate and the data that we receive are ultimately processed by application. So that's why really every useful data is originated at application. However, this useful data cannot go out on internet without any additional information. So there are a number of additional information that needs to be added before this data can be processed and sent to the final destination. So what happens is, at application layer, it builds the data, and then this application will send the data down to the next layer, that's the transport layer, to add additional information. Now we'll touch base a little bit on what is transport layer, what is the function of transport layer. So the function of transport layer is to be able to identify, or to be able to give you to pass this data to specific applications. If you take an example of a computer, in a computer there could be different applications. You might have a web browser, and you might have a telnet application or DNS application, or so many different applications might be there on your computer. Now if data reaches your computer, how does the computer knows that which applications this data is for? So the purpose of transport layer is, one of the function of transport layer, or most critical function of the transport layer, is to be able to create this segregation and pass this data to the specific application that this data is for. So the way transport layer does that is, in TCP/IP protocol, is it has a set of port numbers. So these port numbers are used to identify each application in the computer. And in TCP/IP protocol stack, two most commonly used transport layer protocols are TCP and UDP. Now we'll look at, in this diagram, what really happens. Now application generates the data, and the data moves to transport layer, and as it reaches transport layer generates its own information. We call it header, and this header gets added to the original data. Right? So now you have the basic data that was generated by application, and you also have on top of it the header information from transport layer. This information is now passed to the next layer. What is the next layer? Next layer is internet layer, An internet layer is the layer which offers the addressing for computers or interfaces, right? So what happens is the whole data plus transport layer header information together becomes the data for internet layer, and the whole thing now moves down to the internet layer, and internet layer now will generate its own header, and the additional information that internet layer will generate will include what is the source IP address of that's generating this traffic, so that the responses can come back, and also what is the destination IP address where this data needs to go to. So that header information will be added by internet layer. Now you have an IP packet or datagram, because this packet has all IP information and also the subsequent higher layer information plus the data. So you have a complete IP packet now. Now this IP packet moves through. IP packets can pass through the internet, because you have the information about the destination server, you have the source IP address as well. However, before it can actually go through on the OIR, it needs the network layer information. The reason it needs network layer information is when the packets moves through the network, it actually moves through the physical layer, where the frames and addressing and standards can be different, right? So most commonly used layer 2 network today is Ethernet. So we'll keep our discussion specific to Ethernet. So what happens next is this IP packet will move to network interface layer, which is Ethernet in our case, and Ethernet will add additional information to this packet, and then that additional information will help this packet to move to the next hop. It could be a machine in the same network, or it could be a router which will then pass on to the next hop, and this way hop by hop it will move to the final destination. So just to sort of recap, right, once a packet is formed, and as it moves from hop to hop, as it moves from one router to another router, and basically the network layer information is added and removed, and rest of the IP information remains same till it reaches the destination, right? So now at Ethernet layer, what happens is a network interface card or network interface layer creates a similar header information, and it adds it to the packet. Now two critical component of network interface header is actually the source MAC address and destination MAC address, because in local area network, in a physical layer, actually the addresses that are used to move the packets are the MAC addresses or layer 2 addresses. So two most critical information in Ethernet layer is the source MAC address and destination MAC address. So now if you can step back, and what is the function of ARP is to be able to create mapping between the IP address, which is used in layer 3 level to move the packet, to the corresponding physical MAC address, right? That's really the function of ARP. Now once ARP builds that information, and this information is added into Ethernet frame as a Ethernet header, now a complete Ethernet frame is built, and this frame can now go on the OIR, and the whole thing will move on the OIR in the form of zeros and ones, right? And then we'll look at the next slide, what happens next. Now if this is a computer, the PC, and as the Ethernet frame moves out through the OIR, it will typically go to a switch or hub, and then switch up or hub will either move it to the specific computer where it should go to, depending on the MAC address, or it will broadcast on every port if it is a hub, right? So that's really how it works, right? Now we'll look at a little bit more details. I think really exactly what happens in layer 2, layer 3 level, right? What happens is we'll take an example of PC1. PC1 suppose wants to send some packet, and in this diagram what we see is there are 3 computers, and they're connected on an Ethernet network through a switch, and then there is also a router, and the router is used to connect to a one network or any device outside the local area network, right? So that's what we have in this topology. And you see that every machine has its own IP address, and there is a corresponding MAC address as well. So as we discussed, you need an IP address because you need to at TCP IP level, at IP level the addressing schemes is really IP. And if you have to move beyond your local network, you must have an IP address. Whereas to communicate locally at the bottommost layer, you must have a MAC address. The reason you need to have a MAC address is IP is a little bit at the higher level, and IP allows you to move from one network to another network. Whereas if you have to communicate within the network, there are different kind of network standards within the local network. It could be Ethernet, it could be something else, it could be frame relay, or there are different kind of networks, and each of them could have their own addressing scheme, right? So that's why there is a segregation between your IP layer 3 addressing and your network level addressing, interface layer addressing, right? So in this case, we had an Ethernet network. So you see that you have an IP address which is typically easy to remember and understand, and then you have a MAC address which is kind of a hexadecimal numbers. It's a 48-bit number, which is practically very difficult to remember. So you don't really have to remember this this number. So what happens here is, if PC1 wants to communicate to PC2, what it's going to do is it knows that IP address of PC2. It could either know, depending on the application, if you have configured the IP address on the application, it will know automatically, or it could in turn use DNS to find out exactly what is the IP address it needs to communicate to. Now if we take an example of ping, right, we as a network administrators or system administrators use this ping extensively. So a system administrator and network administrator knows what is an IP address. So you typically ping, use the ping using ping, then the IP address. Now when you do that, what happens is the PC, the ping is an application here. Now ping will, the application ping will create your basic ICMP level information. Now that information then moves on to the network layer. It moves on to the IP layer. In IP layer, source IP and destination IP gets added, and then it moves on to the network layer, network interface layer. And at network interface layer, it will add MAC addresses, right? But where does it find out the MAC addresses from? The place to find out is really, there is a table that this PC maintains with a mapping of its IP address and MAC addresses. So it will go back and look at this table called ARP table. In this table, if MAC address is already present, then it will take it will take that MAC address, and then it will put that MAC address in place of destination MAC address. And source MAC address, obviously the PC can find from its own interface card, and that's how it builds the frame. If you remember the previous slide, it builds its frame with source MAC address and destination MAC address in the Ethernet header, and then it can pass that packet on the wire. So that's really what happens. So we covered the first example where the PC1 wants to go to IP address 192.168.2.51, and then it looks at this table and it finds out the MAC address, and then it uses the MAC address to build the Ethernet frame. Now what happens if this MAC address is not present on this table? For an example, if we take this scenario where the MAC address, the ARP table does not have any information about 192.168.2.51, then what happens? So what will happen in this case is now the ARP protocol will get activated, right? So ARP protocol's function is going to be to go back and find out what is the MAC address corresponding to this IP address. So what ARP will do is ARP, as it doesn't know what is which machine has this IP address, is going to ask everyone who has this IP address and what is the corresponding MAC address to it. And then the machine which has the right IP address is going to respond back with its own MAC address. So if I can use an analogy of a real life scenario, now if you go to suppose you are looking for someone called Rajesh, and you don't know how Rajesh looks like, right? Who is the person Rajesh? But you know that Rajesh is there in the room that you went in, and there may be around 5 people in the room. You don't know who is Rajesh. So what are you going to do? You're going to ask, who is Rajesh? I need to talk to Rajesh, right? So Rajesh, as he hears that someone is asking for him, he will say that, here I am, let's discuss, right? So our protocol pretty much works in similar kind of mechanism. So what ARP will do is, as PC1 needs to talk to PC3 for an example, right? What PC1's ARP protocol will do is it will ask everyone on this network, saying that who has the IP address of 192.168.2.51. Now there is only one machine which has this IP address, which is PC3, and PC3's ARP protocol stack is expected to respond back saying that, here I am, and this is my IP address, and this is my MAC address. And subsequent to this, every communication will happen directly between PC1 and PC2, right? So now, you know, the first step, as you can realize, first step for PC1 is to generate a specific kind of ARP packet called ARP request, and this message will be sent to every machine on the local area network. And that way you do is you use a broadcast address. So broadcast MAC address in Ethernet is all ones. That means in hexadecimal will look like FF, right? So that's how really ARP works. And then once this message goes to all the PCs, only PC3 will respond back. But PC3 knows that this request came from PC1, so it doesn't have to broadcast to everyone. It will send a targeted response to PC1. And once PC1 receives the response, it will build its ARP table with this MAC address, and now actual protocol communication can start. Now all subsequent communication between PC1 and PC2 can directly use this MAC address and in return path this MAC address, and they can communicate to each other. So I hope that very briefly explains what ARP is about and how does it function. Now what we'll do is we'll also look at a little bit more practically what really happens, right? So we'll go to command prompt. At command prompt, you can we'll see what is how is an ARP table look like on this machine. So ARP -A is the command to see. This command will show you all information about the mapping that we talked about in ARP table, right? So you see what it's showing is there is an internet address, that's the IP address, and then there is a physical address, which is the layer 2 address. So there is already a mapping being formed between 192.168.0.1 and this MAC address of B0 C5 54813768, and the flag dynamic is saying that this mapping was created automatically by ARP protocol. And you also see at lower stage, right? You see 192.168.0.255. That's the broadcast address, and that's mapped to a MAC address of FF, which is really the broadcast MAC address. And this is this is not a the automatically generated. When I say automatically generated, it's not a mapping generated by ARP protocol, but this is a system mapping. That's why it's a static mapping. So that's always, the broadcast addresses are always mapped to FF MAC address, right? So that's really this shows. Now there are many other options for ARP. You could look at ARP /?. Will show you all the options. We'll not get to that. And what we'll do is now is we'll actually look at we'll capture some packets and try to see. We talked about that for ARP, the PC1 will ask everyone, who has this this IP address, and someone will respond. But really, practically, how it happens, how does the ARP packets looks like? We'll look at that. The way we'll do is, I have Wireshark installed on my computer, so I'll start Wireshark, and then what I'll do is I'll start capturing some packets, and then we'll generate some ARP packets. So this is my interface, and I'm using this wireless interface, so I'll start capturing on my wireless interface. And now what I'll do is I'll just filter for ARP packets. Okay, so we don't see anything, because probably I already have all the necessary mapping. So what I'll do is I'll ping an IP address for which the mapping doesn't exist. So the IP address I'm going to ping is 192.168.0.105. So what this is going to do is, because the mapping doesn't exist, if you recollect what we said, okay, so what this is going to do is, if you recollect what we said here, the PC1, as I try to ping 0.105, it will come to this ARP table, and we have looked at ARP table just a while ago, and there was no mapping for this this IP address. So the system will activate the ARP protocol. Right? So you see, we are pinging, and what's happening here is a series of ARP packets. Right? So now we look at all these are ARP requests. Right? So as you see, this section, the second window, shows a little bit more details about these ARP packets. So you see that this ARP request is being generated from the source MAC address. This is my MAC address, and it's going to destination MAC address of FF because this is the broadcast address. So basically this is reaching every computer on this network. And then how does this request look like? Right? This is actual ARP section. Right? What ARP section is showing, this is an opcode of 1. That means that this is an ARP request. Basically, I'm asking, I need to resolve this IP address to MAC address. And then the sender is this is my MAC address, and this is sender's IP address. This is my IP address because this section is known. Right? Now target in this case is 192.168.0.105. That's the IP address that I want to find out what is the MAC address for, and then 0.0.0.0 is really the fact that we don't know what is the MAC address. We are saying that this is 0.0.0.0, right? So that's how an ARP request looks like. But in this case, what happened is you see that ARP request went in again and again multiple times, and there was no response because 192.168.0.105 this IP address doesn't exist, right? So basically we have seen a situation where ARP requests were generated and there is no response that came through, right? You see, if you look at the ARP table, you see that there is no mapping got created, right? So that's really is a failed scenario. Okay. Now, why I have shown a failed scenario is sometimes this scenario is also very useful. This can also tell you some useful troubleshooting information. I'll give an example. Suppose, typically, how do you find out if there is a machine connected? If you are troubleshooting a connectivity issue, you could possibly be trying to ping an IP address like 192.168.0.105, right? Now, normally you'd expect 105 to respond back, but there could also be a scenario where one ICMP is disabled. There are many devices which disables ICMP. For example, if you're trying to ping a firewall, it's very likely that firewall is not going to respond back. Then how do you know whether the physical connectivity is good? One way to know at least the physical connectivity is if you generate a ping, it's going to generate an ARP packet, and as an ARP response comes back, this table will get updated. Even though ICMP response didn't come back because firewall has blocked it, the fact that you see ARP response, the ARP response came back, that means that there is a physical level connectivity at very minimum, right? So that's one troubleshooting tips and how you can use this ARP to find out connectivity. Okay. Now we'll look at a little bit more a working scenario, right? Because we saw how a ARP request is like, but how the ARP response will be like, right? So now you can see in the meantime there was another ARP request got generated. Now this time it was for actually for my machine. Look, probably it's 101 is the IP address of my machine, right? Let me confirm, is it for my machine? Yeah, it's for my machine, right? So this time someone is asking, right, who has 192.168.0.1, it's pretty much the same thing. You see there is a broadcast request that came from this MAC address, and this is a D-Link MAC address, and he's asking everyone who has 192.168.0.1. Right? And oh, my bad. Okay, this is once again another request that generated from my machine. Now this time what's happening is my machine is trying to find out what is the MAC address for 192.168.0.1. Right? So my machine has sent a broadcast request to everyone asking who has IP address of target IP address of 192.168.0.1, and the MAC address field is blank. Now you see in next response what happens. This is the next response, right? The response says that now 192.168.0.1 is responding back now, and now you see the destination is a specific MAC address. It's not a broadcast MAC address anymore. Now 192.168.0.1 is responding back, but he's the sender now, and it has added its own MAC address, and of course it knows what is my MAC address and IP address because I had sent the original request, right? So once this packet comes in, this helps us to build that mapping, right? So I hope this explains how ARP protocol builds the mapping, and why this mapping is important to for TCP/IP to function, right? So that's really what I wanted to cover. Thank you very much for your attention. If you have any further questions about ARP, and yeah, I'll be more than happy to respond to that. You can add your comments, or you can send me an email at cms.hannur@gmail.com. And also in subsequent sessions we'll probably cover a little bit more. ARP has its various challenges, and it could have potential security issues, and various kind of security attack can happen based on ARP. Now we'll keep our scope simple, we'll keep it basic, but if you want to know, I'll probably cover in future, I'll take a session on ARP and its potential security issues, and sometime in the future. Okay, all right, thank you very much for your attention, and have a great day.